I use a combined approach for all factorised questions. I'll talk about it abstractly for like 15-20 seconds and I'll dive into a load of examples. I use two steps. The first step is I say, is there something that they've got in common? Something that I can take out, which might be like a 7 or an X or that kind of thing, and then leave everything else inside. Or do I need to, and then, so that's like the first thing, and then I keep repeating the first step to make sure there's nothing else I can take out of the brackets. Then the second step, I try and make double brackets. Right, let's do an example. Okay, so let's use step 1. Is there something that they've got in common? Yes, they've got a 5 in common. So that's 5 times P plus Q. Let's try again. Is there anything else they've got in common? No. Can I do double brackets? No, that doesn't look like something I can do double brackets with. So that must be the final answer. Let's do another example. So I think you're getting the hang of how this video works. We're just going to plough through a load of examples. First thing, is there something they've got in common? Actually, yeah, there is, which is they've got an X. So this is an example of how I think my method is very useful, because a lot of people might miss that and immediately try and do double brackets. But every time you factorise, first try and find something they've got in common. Okay, what do we do next? We try again, because it's really important to try again. Is there something else they've got in common? No, but it's good that we check, because if it did, that would have messed it up. Now we try and do double brackets. Obviously that X just sits there. It's not likely to go anywhere. Now we're trying to do double brackets. My method of double brackets, which I'm not going to talk about here, but anyway, x times x. Then the second thing I do is try and make the 6. I need to make the 6. That could be 1 times 6 or 3 times 2. 3 times 2 will work. There we go, because that makes the middle bit work as well. And that's the final answer. Let's do another one. Okay. The first thing we want to do is, have they got anything in common? Actually, they've got an X in common, which is handy, because again, I think a lot of people would have got distracted early on trying to do double brackets, but always try and do single bracket first, or take something out they've all got in common. Let's try that again. Is there anything else they've got in common? I can immediately say they haven't got anything else in common, because that's a 1, and we're not going to take a 1 out. So then the only other thing is, can we do double brackets now? The double brackets, my experience is this is probably the most creative bit of maths that I know, apart from like problem solving geometry and all that sort of stuff. But in terms of algebra, because you kind of have to just predict what it would have been to make this. Anyway, I don't see a way of doing double brackets with that, because it doesn't look like any of the standard patterns I'm used to seeing. So that'll be the final answer. Oops. The screen just went a bit weird there, sorry about that. Let's do another one. Okay, have they got anything in common? No, which means you don't need to repeat that step. So immediately go into double brackets. Now, it must be x times x makes x squared. What times what makes 9? Well, it must be a plus and a minus, because a plus times a minus makes a minus. So a plus times a minus makes a minus. So, and it can't be plus times plus, because that's a plus. And it can't be minus times minus, because that makes a minus. And makes a plus, sorry. So it has to be plus and a minus. And then you can use symmetry to work out it's a 3 and a 3. Or you might just recognise it as complete the square. Not complete the square, difference of 2 squares. But I don't think you need difference of 2 squares knowledge to answer a question like that. Let's do another one. Factorise fully. Let's take out, well, they've both got an x, so that'll be x to the 10 minus x to the 6. Oh, wait a sec. There's a lot more x's than that. Let's keep repeating. Let's take out another x to the 6, which makes a total of x to the 7 on the outside, which makes x to the 4 minus 1. Let's try again. No, there's nothing else we can take out. Now we try and do double brackets. The x to the 7 just sits there. I'm not writing equal signs here. I'm being a bit lazy. Can we do double brackets? Well, actually, it looks quite promising, because I would argue, because I recognise it, I think the double brackets is just I think it's just more practice. You could do x squared times x squared. Because the crucial thing there for me, in terms of the way I think about it, is that's an even number. So that's quite easy to split up. I mean, you can have odd numbers as well, but it just makes it more obvious. Anyway, and then do +1 -1 because that's the only way I can think of to make -1. Multiply out to check it works. It does work, so that's the final answer.